Welcome back, everyone. In this video, module 2, part 2, we are going to learn about sampling and distribution. So, sampling is defined as choosing a subset from set of n distinguishable objects. That is called as sampling, and then that subset is called as sample. Distribution or distributing is called as assigning or distributing markers to n different objects. So the same concept, but in two different perspectives. So removing balls from urns, and so that's you can consider as a sampling, and then distributing balls into different urns, that's you can think about as distributing. So it's a different, same concept in different way. So let's consider a set of n distinguishable objects. Then this set of an object called as population. So let's say we want to answer how many distinct sample of size r can be drawn from the n object. Now, when someone asks this kind of question, of course, we need to know more thing, whether we are allowed to replace. Is it a sampling with replacement or without replacement? Without knowing that, we cannot really answer this question. So in order to answer the previous question, we need to answer two related questions. Are the sample taken with or without replacement? Does the order in which we select the item in the sample matter? Okay. So we need to know these two questions. So with or without replacement, and then the order of selection. Is that going to be matter in this case? Once we know that, then we can answer the question, how many different sample of size r can be drawn from the n objects. So there are four types of sampling problem based on that. You can have ordered sampling without replacement, unordered sampling without replacement, ordered sampling with replacement, and unordered sampling with replacement. So based on this idea, with or without replacement and the order, we can come up with four different sampling problems. So let's say first question, calculate the number of 5-letter word with no duplication of letters. So, so we want to answer this question. So this is ordered sampling without replacement. So no duplicate, and 5-letter word. So we want to know how many outcomes are possible. So if I think about this, like if I draw the placeholders, let me draw. So there are 5, so I can draw 5 placeholders. So first one, I can pick any letter, 26. Okay, so there are 26 letter alphabet. Then this next one, I can choose 25. And next one, 24. Next one, 23. Next one, 22. So this is what? This is, if you look at this number, this is basically 26 factorial divided by 21 factorial. Or in other words, it's 26 P5. Okay. So this is the answer for this one is going to be what? That's going to be 26 P5. So the order matter, how you select, and no replacement. Okay, so then 26 P5. The next one says calculate the number of 5-letter word with no duplicate letter and the letter arranged in alphabetical order. Okay. So this is unordered sampling without replacement. So the letters arranged in alphabetical order. So that means the once you pick those 5-letter, the inside we are representing by one word. Like for example, if you have like ABC, BAC, and CAB, all of these replaced by one, ABC. Okay. Or this is basically what? This is basically a combination. So we have 26 and we want to pick 5. So the answer is going to be 26 factorial. 5 factorial and 21 factorial. So that's the answer for this one. 26 C5. So you pick no duplicate letters. You pick 5 letters without any duplication, and then letter arranged in alphabetical order. Okay. So so it's unordered sampling without replacement. So the next one says calculate the number of 5-letter words, duplicate letters allowed. So if that's the case, if I draw the placeholders, I can choose any letter for the first one, 26. Since I am allowed duplicate, I can pick any for the second. And again, 26, 26, 26. So the answer for the next, this one would be what? 26 to the power 5. Okay. So that is order sampling. So for example, if this is A, if you pick first one to be A, then this one B, C, D, E, then that's 1. Okay, so, and the second one, let's say you pick the B here, and this is A, C, D, E, that's a different word. We are not considering they are same. So that's order sampling with replacement. The last one asks, calculate the number of 5-letter words, duplicate letter allowed, and the letter arranged in alphabetical order. So now we can't use this method. To answer this one, we have to have different formula. We are going to do that in a few minutes. But as of now, we don't have an answer for that. So here you can see that we are trying to go to the other side, distributing. Each of 4 types of sampling problem has dual formation. So now we want to reformulate the sampling problem in a distributing setting. Okay. So we use urns and balls in this setup to explain. Okay. So let n be number of distinguishable urns. So you can have urn. And let R be number of balls to be distributed into urns. Okay, so you can distribute. So if you have balls like this, then that means it's indistinguishable. Okay, so think about like urns like ABC. Or you can have distinguishable balls like you number it. Okay. So for example, 1, then here you have 2, then here you may have 3. Then you may allow duplicate or no duplicate, exclusive or non-exclusive. If it's exclusive word, then you can have only one ball there. Okay, it's either like something like this or something like this. If it's non-exclusive word, then you can have more than one, something like this or something like this. So the same question converted to distributing problem. How many different distributions are possible? So in earlier we asked what? We asked the question was how many different distinct sample of size R can be drawn from the n objects. So in order to answer this question in the same way, under distributing setting, we have to we need to know few things. Whether urn hold at most one ball, which is exclusive, or more than one, non-exclusive. Exclusive mean without replacement. Non-exclusive mean with replacement. And then other balls are distinguishable or indistinguishable. If it is distinguishable, then there's an order. If it is indistinguishable, then there is no order. Okay, unordered. So the same question here you can see convert it to the distributing setting. So calculate the number of 5 letters word with no duplication of letter. That is a sampling problem. Then in under the distributing setting, it would be how many ways 5 letters can be selected from 26 letters alphabet with no duplication of letter. So that means basically if I try to draw this, then the urns look like this. The last one is Z. Then 5 letters. So I can, this exclusive urn, so I can put only one. So it can be one here. This can be 3. Then this can be 2. Then the letter we are creating really is A, Z, C, because this is the first, this is the second, this is the third. Okay, so there's a order. So this one, and if I try to come up with this one, so that's one. That's basically A, Z, Z. And these are going to be different. Next one is calculate the number of 5-letter word with no duplicate letter and letter arranged in alphabetical order. So that's exclusive urn but indistinguishable. So if I try to draw this, visualize this, I have urns like this. And then indistinguishable. So it's exclusive. Okay, so what's the letter? Letter is A, Z, Z. Okay. Now let's say I change these two balls. Still I get same because the balls are indistinguishable. Okay. So that's this one. Then the next one is calculate the number of 5-letter words, duplicate letter allowed, non-exclusive and distinguishable. So if I try to draw this, so these are non-exclusive ones, so I can put more than one ball and distinguishable. So it can be something like this: 1, 2, and 3. So what's the letter? Then the letter is going to be A, Z. So let's say I put 2 into this and 3 into this. Then I would get a different one. It would be A, Z, A. So we get different with different result. Then the last one is calculate the number of 5-letter words, duplicate letter allowed, and the letter arranged in alphabetical order. Non-exclusive urn, indistinguishable ball. So if I try to draw this, try to visualize it, I have A, B, C, Z. So now it's non-exclusive urn and indistinguishable ball. So I can have something like this. Okay. So which is going to be AAC. Now changing these two, It's not going to make any difference. It's still same. So here you can see the equal expression. So under the sampling, ordered sampling without replacement, under distributing is distinguishable balls exclusive earn, and so forth. So you can read this and see the similar expression from the other side. These are the equal formulation. So, so let's go to the one we want to answer. So the question says, calculate the number of 4-letter words, duplicate letter allowed, and the letter arranged in alphabetical order. So duplicate letters allowed and the letter arranged in alphabetical order. So the formula for this one, let me go to the formula first. When you have this kind of problem, the formula would be n plus r minus 1 choose r, or n plus r minus 1 cr. So so that's how you answer that particular question. So in our case, if it is 4-letter, then we have 26 plus 4 minus 1, and then 26 minus 1. Either we can use that one or we can use the first formula. They're both going to give the same answer. You can calculate and see. That's the answer for this one. So how many number of ways you can do this? So this 26, you can kind of like think this as sticks. Okay, so so let me draw like this. Okay, so I can use sticks to make the difference between A, B, C, D. So this side A, this is B, this is C, so forth. And the last one is Y, and then this side you have the Z. Okay, so I mean, let me draw something like this. So this is Y and this is Z. Okay. So you need 26 minus 1 sticks. Okay. So then let's say it's 4-letter word. So the letter words, you allow duplicate letters. So you can have more than one dot in urns, or you can draw like this. Okay. So this is, let's say this is D. Okay. So this one letter. So this is going to be what? A, C, D. Okay. Now you can move this stick to here. If you do that, then you would get different word. It would be A, B, C, D. Okay. So if we think about this way, then it's look like we have 26 minus 1 sticks plus 4 letters, that many objects. And out of that, we are going to pick 4. Okay. So that's how this formula was developed. So here you can see the summary table. If order matter and without replacement, you use NPR. Order does not matter without replacement, you use NCR. Order matter with replacement, n to the power r. Order does not matter with replacement, then n plus r minus 1 CR. And then this side you can see the distributing formulation for the same problem. So now you can see the binomial theorem. It is actually application of combinations. So let's say you try to expand this. Okay, and of course you know there are nx and ny. So if you want to know the coefficient of x to the power r, then of course there are, you know that there are nx to choose, and then from there you can choose r. Okay. Then for the y, it's going to be fixed because it's already decided. Because once you choose the x to the power, y power is already decided. So that's what this basically idea in binomial theorem. The same one you can expand to the multinomial. So this is multinomial theorem. Then we learn about this multinomial coefficient. So that's it. That's the end of module 2, part 2. We will do some sample problems from SOA for this module.